Hello students, in today's session, let us discuss the steps involved in urine formation. Before I begin the physiology of urine formation, let me revise the earlier session where we have learnt the structure of human excretory system followed by histology of kidney and ultrastructure of nephron, which is also called as uriniferous tubule. Here, a paired kidneys, paired ureters, opening into bladder, which opens out through urethra. Kidney is an essential organ in excretory system comprising renal cortex and renal medulla. Medulla extended in the cortex, forming triangular regions called renal pyramids. On the wall of renal pyramids, minute tubular functional units are located called as nephrons. Each nephron is divided in two regions, Malpighian corpuscle and tubular region. Malpighian corpuscle comprises cup-shaped anterior end of nephron known as Bowman's capsule, which has inner podocytic visceral layer, outer parietal layer, and the space between visceral and parietal layer is capsular space filled with the capsular fluid. The blood entering in the Bowman's capsule through afferent arteriole, whose diameter is bigger, and the blood vessel which leaves the Bowman's capsule is efferent arteriole. The branches of afferent arteriole for efficient filtration of the blood in the Bowman's capsule, forming a network known as glomerulus. So now the glomerular capillaries through which blood is flowing and the visceral layer of Bowman's capsule together forms blood urinary space barrier. This is the region of filtration of the blood to remove unwanted nitrogenous waste like urea, uric acid, and along with that creatinine, hippuric acid, and some electrolytes and metabolic water. So this is the region of glomerular filtration, first step in urine formation. The next region of nephron is tubular region, differentiated into proximal convoluted tubule lined by brush border. It descends down in the renal medulla, ascends up and entering in the renal cortex, and again it gives a convoluted portion known as distal convoluted tubule, whose one limb is very close to the afferent arteriole. So the blood vessel which enters the nephron is afferent arteriole and one limb of DCT. Both are very close and surrounded by a special cord composed of muscle fibers surrounded by special epithelial tissue called macula densa. This forms juxtaglomerular apparatus. And then DCT opens into collecting tubule or collecting duct. Collecting duct on either side of renal pyramid will take the urine towards the renal papilla, where the calyces receives the urine and give to the renal pelvis, and then the renal pelvis will take the urine towards the bladder. Till it goes in the bladder, selective reabsorption of water is continuous, making the urine more and more concentrated. This you will understand in the next few minutes. This is the region of nephron. There are three steps in urine formation. Glomerular filtration, it occurs in the Malpighian corpuscle. Selective reabsorption is the second step, where the essential elements which are filtered in the glomerular filtration step are collected back by active transport, by osmotic movement, and by passive movement. So essential elements from the filtrate is received back into the interstitium and then it enters the blood capillaries. It is partly in PCT, then in Henle's loop, and then in DCT. Third step, when selective reabsorption is going on, chances are there that some waste molecules from the filtrate may diffuse out along with the essential elements. So, these elements which are toxic to the body will remain in the interstitium or around the nephron. So, all these non-essential toxic elements secreted back into the DCT. It is known as tubular secretion. Here, the entire region of nephron has to be selectively permeable. According to the interstitial fluid and the nature of the filtrate flowing through the tubular region of nephron, the membranes has to change their permeability, and it is under the influence of a hormone secreted by a neurohypophysis known as ADH, antidiuretic hormone or vasopressin. That I'll be covering in the next session. Now, let us study one by one 3 steps in urine formation. The blood through afferent arteriole entering into the Bowman's capsule. As the diameter of afferent arteriole is bigger than the efferent arteriole, naturally incoming blood is more. So, when blood starts flowing in the glomerular capillaries, the capillary wall will experience glomerular hydrostatic pressure, the pressure exerted by the blood on the walls of glomerular capillaries, and it is approximately 70 mm of Hg as it is measured in mercury column. So when GHP is rising due to incoming blood and the blood started flowing in the glomerular capillaries, then the capsular fluid present in between visceral layer and parietal layer, it also exerts the pressure in opposite direction. So one pressure from glomerulus towards the visceral layer of Bowman's capsule, and another pressure is exerted by capsular fluid towards the visceral layer. So GHP is 70 mm of Hg while CHP is 20 mm of Hg. As GHP is higher than CHP, the filtration begins. This step we call ultrafiltration. Under this pressure, the filtration continues. When filtration begins, there are colloids present in the blood. Corpuscles are also present in the blood. The proteins which forms the colloidal particles and the corpuscles, they start adhering to the capillary walls. They exert their own pressure which is reducing GHP. So the particles which are obstructing the filtration of the blood in this region exerting their own pressure known as colloidal osmotic pressure. But filtration won't stop. COP, colloidal osmotic pressure, is approximately 30 mm of Hg. GHP is 70 mm of Hg, which is positive pressure, favors filtration of the blood, but CHP and COP, these two are negative pressures which are obstructing the filtration. If you want to find out under which pressure filtration continues, then you must find out GHP, then you must find out CHP and COP. So, when you substitute the values, effective filtration pressure is equal to GHP minus CHP plus COP. As earlier I said, GHP is 70 mm of Hg, CHP is 20 mm of Hg, COP is 30 mm of Hg. So substitute the value 70 minus 20 plus 30. Next step 70 minus 50. So EFP, effective filtration pressure, is equal to 20 mm of Hg. This value indicates that pressure is higher in the glomerular capillaries than the capsular fluid. So this is more than enough to filter the blood in the Malpighian corpuscle region with the help of glomerulus and the visceral layer of Bowman's capsule. The filtrate collected in the capsular space after filtration of the blood is known as primary urine or nephric filtrate. It contains both essential and non-essential components. Filtrate is now flowing into the PCT, and the outer fluid around the nephron, right, it is interstitial fluid. Now we have to compare the concentration of filtrate and concentration of the fluid in terms of solvent and solutes. So if you check the nephric filtrate collected in the capsular space and the interstitial fluid surrounding the nephron, both are isotonic. Means the solvent and solutes are approximately equal. In this situation, selective reabsorption is impossible. So in PCT, the cells lining provided with the brush border, these are flagellar extensions of the cuboidal epithelium to increase the area for absorption. These cells utilize ATP molecules, accumulate the solutes in the filtrate, making it hypertonic. So this is an active phenomena. So they are using energy molecules to increase the solute concentration to make the membrane of PCT permeable so that nutrients like glucose, amino acids and some fatty acids which are there in the nephric filtrate, they start moving from higher pressure to lower pressure. So filtrate started losing nutrients now added to the external fluid. Along with the nutrients, electrolytes, sodium and chlorides, bicarbonate ions, these are also essential. They start moving out through the special membrane bound receptors. This is also an active phenomena. At the same time, from the fluid, NH3, these are the gaseous molecules, and hydrogen ions H+, they start diffusing in from higher pressure to lower pressure. So now when the filtrate start flowing through the PCT, it started giving nutrients, it started giving electrolytes, it started giving bicarbonate ions. At the same time, the fluid will give H+ and NH3+ into the filtrate. So when that filtrate comes towards the Henle's loop, when it starts moving toward the descending limb, and when you compare now concentration of the filtrate with the surrounding fluid is now hypertonic because all these reabsorbed elements are available in the filtrate. Clear? And the filtrate already lost all these elements, so the nature is hypotonic. So fluid is hypertonic, filtrate is hypotonic, and the wall of descending limb is permeable to water. So naturally, by osmotic phenomena, the water solvent will move from filtrate to fluid. So as the filtrate passing down the descending limb, slowly it becomes hypertonic due to osmotic movement of water, and the outer fluid becomes hypotonic. So when it comes in the lower portion of Henle's loop, filtrate is hypertonic, interstitial fluid is hypotonic. As the filtrate passing up, the membrane is impermeable to water. So though outer fluid is hypotonic, water cannot enter in, but the wall is permeable to electrolytes. So here, when filtrate start moving up, it loses maximum electrolytes. It is selective reabsorption of all essential mineral salts, which will make the filtrate hypotonic again and outer fluid hypertonic. Thus, the filtrate start moving into the DCT. 5% of water may reabsorb through the DCT, and then it is given to the collecting tubule. So on the way of DCT, from the fluid around the nephron, whatever unwanted components are there, they are accumulated and they are secreted, which is the third step in urine formation. This we call tubular secretion. So the process in which the nephric filtrate, which is isotonic, passing through PCT become hypotonic, Passing down the descending limb, as the limb is concentrating segment, allowing movement of the water, it becomes hypertonic. As it started moving up, again it becomes hypotonic due to reabsorption of mineral salts, and again water is reabsorbed. Tubular secretion will add non-essential elements back to the filtrate. This filtrate is now we call urine. The process of making the isotonic nephric filtrate into hypertonic urine is known as augmentation. So the process of augmentation will continue till the urine reaches the bladder. With this, I'll conclude this session with 3 steps in urine formation: glomerular filtration, second, selective reabsorption, third, tubular secretion. Glomerular filtration is occurring in the Malpighian corpuscle, selective reabsorption partly in PCT, partly in descending limb, partly in ascending limb, partly in DCT, and tubular secretion is in the DCT. When this process is going on, in the renal cortex where Bowman's capsule, PCT, DCT are located, their osmolarity is quite lower, approximately 300. But when you see the osmolarity, it is a solid concentration. In renal medulla, it is quite higher, 1200 mm. This is enough to continue selective reabsorption and tubular secretion. With this, I'll conclude the phases involved in urine formation. Thank you.